Okay, we're going to have a short discussion about welding. Welding is neat. I always wanted to be a welder. You have to be certified to be able to weld. We were talking about bolted connections, and in bolted connections, um, the requirement for uh, for somebody that's putting together bolted connections, there are none. So, so you or I could get up there in a building and we could tighten the bolts. I guess if we had a wrench, we'd be, you know, we'd be good to go. So with welding, you actually have to take a course and learn how to weld. Let me get it up here. Here we go. All right, let me get this on the screen. And here we go. As I mentioned to you, welding's kind of neat. There are two kinds of welding. Um, People don't weld with torches much anymore. Um, my wife won't buy me an electric arc welder because she thinks I'll burn the house down. So I sit out there with a torch and some and welding electrode, and I try to weld two pieces of steel together, and that doesn't work, and that's no fun at all. So I'm going to keep working on her until she'll get me an electric arc welding electric arc welder. One of the main things you have to remember, if you get an electric arc welder, which I'm sure all of you will go out shopping and find one. Um, they're kind of dangerous to use. It's like a battery, and you hook a couple leads up to the battery, and then when you touch the leads together, you create an arc, which makes the weld. So welding is not like gluing. We're not going to take two pieces of steel and glue them together. The welding actually fuses the two materials together. So the base material and the weld material are fused together so that the weld is permanent. Obviously, we're going to see there are lots of different kinds of welds. So so let's get started here. You need to have your welding mask on and your gloves to be able to go through this, because this is pretty high tech stuff here. Oh, you have to be licensed as a welder. There's a 40-hour course that you can take at ITT or one of those institutional educational facilities. ITT is one, or whatever the tech, one of those tech, uh, 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 I don't know, the tech classes that you can find. You can learn how to weld. It's about a 40-hour course, and you're tested on the quality of the weld when you're done and all that sort of stuff. And you get a certificate suitable for mounting that says you are an official uh, an official welder. And if we were to look at specifications for structural steel, we would find in there are specifications for welds, and we'll have time to take a look at that. That's one of those documents that you can read that'll kind of put you to sleep, and it's AWS, American Welding Society document that goes through welding. Additionally, If you're interested in welded connections and how they work and what you can weld together and what you can't, um, I'll give you um, uh, the name and author of the books that I have on welding. The best one is called Welded Structures. It's a book by Blodgett, and I'll write that down up here on the screen in a minute. But every engineer, designer's got a Blodgett book on hand so that you can pick up the finer elements of welding design. So welding is the process where the metal parts are connected by heating their surfaces to a fluid state to allow the parts to join. That heating of the surfaces, as I said, can be done with a torch or with an electrode. Both the torches aren't used much anymore. Welding saves money over bolted connections because it eliminates the need for gusset plates and splice plates. You want to splice two pieces of steel together. You can simply put the two pieces together and then take the electrode and off you go. You can weld those two pieces together with what's called a penetration weld, which would fully penetrate the thickness of the welded part, so that the weld is just about as strong as the the original steel uncut member would be. Welded connections are possible in connections that, just a sec here. VPN connection stopped for some reason. Going here. Doesn't give you much time. There's the pause. Okay. Connections that would be difficult to bolt. Remember, we had that picture of the angle bolted to the steel beam, and we had to stagger the bolts to be able to get a wrench on them. And part of our problem in bolted connections was the fact that the bolted connections, we had to figure the size and area of the bolts and check them out and all that sort of stuff. Fortunately, with welded connections, they're fairly simple to design because a weld has the same capacity and tension as it does in shear. And I'm going to give you a table in here that actually gives you the capacity of fillet welds, which is a type of weld we'll look at. It gives you the capacity of fillet welds in the size of the weld and the capacity in kips per inch. So it's pretty straightforward. The welded structures, all the connections in the welded structures, remember in bolted structures we had type 1, type 2, and type 3. We had the framed connection, and then we had the semi-framed connection, and then the rigid connection. And the rigid connection took 1 million bolts to make the two parts connect without any slippage. Well, with welded structures and the welded connections, you don't need to worry about that. When you weld them together, you have a rigid connection. A lot of architects like welded connections because they're smooth and they look better. Um, it says it's easier to make changes in design and to correct errors during construction. That's true. It's just as fast to put the electrodes on an already welded joint and melt the weld material and pull the two pieces apart and move them where you need them and weld them again. Well, the welds are very simple to do. They're quick and easy, and it's a quiet process, and the welds save a lot of detail. All you do is say, well, we're going to weld these pieces together. Okay. So, okay, so there are the welds are governed by the American Welding Society and the Structural Welding Code that's published by the American Welding Society, and I can give you a link to that, and you can study welding if you'd like. Most all of the welding today is arc welding. Electric arc welding is the easiest way to make a weld. The electrical arc welding is you take a metallic rod known as a welding electrode. It melts into the joint that's being welded. And you can see there that the welding of the base material produces a temperature of around 6,000 to 10,000 degrees. Steel begins to soften and melt around 3,500 degrees. So here's what the welds look like in close cross section. The two members being welded together are in green, and the terminology for the weld, this happens to be a fillet weld, is the throat dimension, which is the depth of the weld. Usually this is the face of the weld is figured at about a 45-degree angle. So the leg and size, these two dimensions match. And there's what the weld looks like. Some pictures of welds. Here's a good picture of a weld. Notice that the weld has ripples or ruffles. Welds have ruffles. What that means is you do a weld and you move the electrode along the material you're welding. It's difficult to move it in one smooth stroke. So you end up moving it in a series of small strokes, and that's what creates the ridges on the weld. The welds typically, if you're welding two pieces of steel together, you can weld the weld material and base material. The weld can have a leg size of about 1/8 of an inch. So if you have a weld that has to be thicker than 1/8 of an inch, every pass that you make is 1/8 of an inch thick. So the welder will start and he'll lay the first weld down, and it'll be 1/8 of an inch thick, and then there'll be a second layer to the weld, and the second layer of the weld is another 1/8 of an inch thick, and it goes on top of the first. So if you had a 1/2 inch thick weld, you have to do that 4 times. The weld would be 4 layers thick. So you can see here we're going to run into a problem. How do we tell if the welder did a good job on the first weld when it's covered by 3 layers of 1/8 inch welds above it? Aha! We're going to find out how in just a minute. So here's another picture of a weld, and you can see these are 2 stainless steel pieces that are being welded together. And the well looks similar to the one that I was just showing you. Um, nice clean well. Here's an x-ray of a weld. So this is what physically happens. This is the base material. This is the weld material. And you can see, like I said, this isn't a glued connection. The base material is mixed, it's heated, and fuses with the weld material so that this weld material is a combination of the original base material and the electrode, both welded, both deposited at the same time during the weld. So we've got two different kinds of welds. The first kind is called a shielded metal arc weld, an SMAW weld. This is the weld that's typically done in the field. What you see here is this is the base material. Here's the weld material that was left behind. Here's the electrode, and the electrode is hooked up to the welding machine. I always tell my classes, if you want to weld something together, and you have to promise not to repeat this to anybody, but if you want to weld two pieces of steel together, you can do it with the jumper cables in your car. You'll hook the jumper cables up to your battery. You know how if you hook the jumper cables up and you touch them together, they spark? Aha. So you take the black lead of your jumper cables and you clamp that, because you have to ground it. If you don't ground it, you're going to get a heck of a shock. Then the red end, the red lead then is the positive end, and this is going to sound crude, but you can take a coat hanger and bend the coat hanger, and you can stick it in that red lead, and then the end of the coat hanger, wherever it touches the steel, it's going to create a spark. And when it creates a spark, that's what you see in this picture. There's the welding electrode. This one is extruded, so you can touch it without getting shocked. There's the base material, and there's the arc that's set up. That's in the arc stream is set up, and you can see it's melting the base material and the electrode at the same time. There is some slag that's left behind that you need to take a wire brush and clean. But this is typically a field weld. It's a shielded metal weld. Now the welds, if they can be done in the shop, the procedure looks a little bit different. The welds are actually covered with a granular flux. So there's a flux that's poured in front of the electrode. The electrode now is hooked up to the machine in the shop. This is untouched by human hands, so the electrode is not shielded, but the idea is the same. Here's the molten flux. There's some slag that's left behind. Here's the molten area of the weld metal. This is the penetration, which would be the size of the weld. So this is moving along, and this creates a smooth weld because it's done by a machine. It's a very good-looking weld. So the welds that are done in the shop are called submerged arc welds, SAW, and those welds are pretty clean looking. So some of the welds that are done in the shop, a lot of times they'll weld the base plates of a column to the column in the shop. If the column has tabs on it, that leaves some beams, then those tabs will be welded on in the shop, and it's a nice clean weld, and it looks better than It looks better than the field weld does. So, as I mentioned to you, welds are hard to inspect because when you get out there, all you see is a weld. It's not like a bolt, with the load indicator bolts. You can go out there and look, and if that fluted end of the bolt is twisted off, you know that the bolt's been tightened. Or if you have load indicator washers, you can take your feeler gauge and check the gap at the washers and see if the bolt has been tightened. Inspecting welds is a little bit different. Visual inspection of the welds um, is not very difficult to do. So visual inspection just means that you walk up there and you look at the weld and you say, yep, that's a good looking weld. Typically, however, visual inspections are only done for single pass welds. So we said that the maximum weld size can be 1/8 of an inch. A single pass weld would be like an 1/8 inch fillet weld. And you could look at that weld and see if it's the right shape and size, if it doesn't have any cracks in it and that sort of stuff. Liquid penetrants are what we use at our office. The liquid penetrants are a dye that comes in a tube or a little bottle, squeeze bottle, and you can put the dye on the weld and just let it soak into the weld. And then there's a developer that comes in a squeeze bottle also, that's a powder, and you blow that powder onto the weld, and then you take a black light and you can run the black light over the weld and see if there are any defects in the weld. So that way you can actually check um, more than one layer of weld, because that penetrant will soak into the lower layers of the weld, and when you put the dye on, the dye will pick up. Sometimes that penetrant will run out of the lower layer of the weld and show. Magnetic particles are neat. You can take iron filings and magnetize them, and you can put them on spread them over a weld, and because they're magnetized, they'll all line up with the weld. So you'll get them all in a line, and if you get to a point where the weld has a defect or a crack in it, the little iron filings stop, and then they start on the other side of the weld, so they're kind of pointing at the crack in the weld. And haven't seen anybody do that, but it sounds like it might work. What really works are the last two methods. The electrosonic testing, sound waves are passed through the weld, and where there's a crack in the weld, a reflection will be shown on the cathode ray tube. So that's just like getting an X-ray or an ultrasound at your doctor's office, and I've done that numerous times here in the last few months, and it's a very useful product. And then the last is to X-ray the welds. Typically, this is extremely difficult, but it's also very expensive to X-ray a weld. It's actually cheaper, for you to get a chest X-ray than it is for you to go out in the field and start X-raying welds. But they show you exactly what the weld looks like. We're only going to discuss two types of welds: fillet welds and groove welds. And of those, the fillet welds are going to be more common. There's what the fillet welds look like if we're welding two plates together. And those are the cross sections that I've been showing you. Those are fillet welds. The groove welds can be complete penetration welds, which means that they penetrate all the way through the base material from one side to the other. And they're called full penetration welds. And that's what I use to splice beams and columns together is full penetration welds. Now, additionally, you can have groove welds that are partial penetration groove welds. And then there's some miscellaneous welds. Here's the fillet weld. The plug welds are used typically, both plug welds and slot welds are used to attach metal deck to steel beams. So if you got metal roof deck, you specify how often you want a plug weld, and they walk along and they touch the roof deck with the electrode. The electrode will actually burn a hole through the roof deck and fuse the roof deck to the steel beam or joist below. So that the plug welds are very efficient. Of the fillet welds, they can be T-welds, edge welds, corner welds, lap welds. You can just about weld anything you want together. Now this is where we'll start on Friday. This is table 8-2 from the Steel Construction Manual. And this is the weld symbols. So this is how you talk to the welder. The welder, he's got a license, so he knows how to read the weld symbol. And you've probably seen them on drawings before, a little line with an arrow, and sometimes it'll have a flag on it. And those are weld symbols that go on your drawings that direct the welder how to weld the materials together. Here are some basic requirements for welding. As I said, welding inspection shall be in compliance with AWS is the Welding Society. D1.1 is the actual document that controls or specifies welds. Okay, so on Friday we'll get into the design of the welds and how much load they'll carry and all that sort of stuff. So we'll do that on Friday, and we'll end the lecture right here. As soon as the recording compiles on the chat, I'll copy it and attach the link to the recording on the announcements part of the Canvas. So that'll be there this evening and tomorrow, and then tomorrow we'll start on the design of the weld.